Definition of appetite and hunger. What's the definition of appetite?
When you're hungry. when your brain tells you you're
Is it specific?
Yes.
Yes. Appetite is something that is specific. I have a specific need for chocolate chip cookies, which somebody asked. Right? Cool if you did. But hunger is what?
your body's telling you you need
And translated into scientific terms, that would be a physiological need for food. So appetite is not necessarily a physiological need, because my 12-year-old always has an appetite for something, but he's not actually hungry. He's just bored. So, yeah, that's the difference between appetite and hunger. What you want to know is the role of each organ in digestion. What's the role of your mouth?
Breaks down carbohydrates.
Well, it starts carbohydrate digestion at that point, right? But it's mostly needed to break the food down through mechanical and chemical means. Mechanical mostly because you're biting your large bite into smaller bites, into smaller bites, and you have salivatory amylase, which is breaking down the carbohydrate. You have mucus, which is going to help lubricate and form this into what? A bolus, okay? What's the function of your esophagus?
Transport.
Transport that bolus from your mouth to your stomach. What's the role of the stomach? Further break down that bolus into a form of liquid called chyme, right? Now, in your stomach, are you digesting carbohydrates? No, because the acid, HCl, that is produced by your cells in your stomach is going to deactivate that amylase. What else is going on in the stomach? Okay, you're having partial digestion of fats and proteins, right? But you also have this churning, yes, muscular churning and mixing of the food. Okay, now you have this chyme, which is a liquid form of the food. Now it's moving from your stomach to what organ? Small intestine. What part of the small intestine? Duodenum. There he is. It said you weren't going to be here. What part of the small intestine? Duodenum, okay. What's going on in the duodenum? There's a juncture here, right? You have a juncture that has a couple ducts that are feeding into it. One of the ducts is coming from the gallbladder, which is going to secrete what? Bile. Purpose of bile. Aids in the digestion of fats by doing what? Emulsifying the fat, making it into smaller particulars so that you can form chylomicrons around them, right? And then you also have the pancreas, which is dumping what into it? Most of the names have pancreatic this and pancreatic that. Cancer? That comes later on in life. You got pancreatic amylase, you got pancreatic peptase or protease, you got pancreatic lipase, right? These are enzymes that are going to be breaking down those three macronutrients, the lipids, the carbohydrates, and the proteins, right? What else is the pancreas producing into that area? Not yet. You have this acidic chyme that's coming from your stomach. So what does the pancreas also have to do? it produces that bicarbonate. That bicarbonate is going to neutralize the acidity of the chyme, right? Okay. So we'll get into insulin and glucagon function later on. So now it's going into your small intestines. And what's the purpose of the small intestines? Absorption of the nutrients, okay? And also to move that food through the intestines. You have muscles that will move it. So you have peristalsis and segmentation going on, right? So now that food stuff has been absorbed, and most of what's going on now, you have either undigested food or waste, and that goes into where? The colon. What's the major job of the colon? Absorb the last 10 to 30% of water and to form the fecal matter. And so it moves from the colon into the rectum, and then from the rectum, hopefully into the toilet. 3 years old and you miss it. Okay, so know the hormones associated with digestion. Know the source, target organ, and function that you're going to find on table 3.2 on the PowerPoint. So let's go to table 3.2 on the PowerPoint. This is chapter 3. Table 3.2. Okay, 3.2. So the hormone gastrin, what is the production site?
What page is it on?
I don't know about the page, but I know
No,
it's
like, 'cause you
PowerPoint.
know how on the PowerPoint it's like 13 out of 65 or?
It's table 3.2. Oh, as far as pages, let me see.
Isn't the study?
Page 34 on the PowerPoint, but it's table 3.2. So gastrin is the hormone. Where is it produced at? The stomach. What's its target organ? The stomach. What is its action? It secretes, stimulates the secretion of hydrochloric acid and pepsinogen. Pepsinogen is an inactive form of pepsin. It's going to also stimulate gastric motility, meaning movement of the stomach, and promotes proliferation of the gastric mucosal cells, meaning that it's going to help stimulate the production of mucus, which is important to protect the wall of the stomach. Secretin comes from the small intestine, more importantly the duodenum. Its target organ is the pancreas and stomach. It's going to stimulate the secretion of pancreatic bicarbonate, which is going to neutralize the acid from the stomach. And it's going to stimulate the stomach to decrease its gastric motility, slow down its motion. You got CCK coming from the small intestine, duodenum and jejunum. It's going to target the pancreas as well as the gallbladder and stomach. It's going to stimulate secretion of pancreatic digestive enzymes such as your pancreatic lipase, pancreatic protease, and pancreatic amylase. I know I'm speaking fast. I can't slow down. We gotta get through it. Okay, so it's also going to stimulate the gallbladder to contract, which is going to produce bile from there. And it's also going to help slow down gastric emptying, okay? And then you have gastric inhibitory peptide. it's gonna come from the small intestine, and it's going to affect the stomach and pancreas. It's going to inhibit gastric acid secretion, slowing down the amount of HCl that's being produced, which also helps with, because that bicarbonate is not gonna be able to do everything, it has to slow it down. It's going to slow down gastric emptying, basically timing out the release, and it's also going to stimulate the release of insulin. Okay. Now, know how food absorption works as far as passive diffusion, facilitated diffusion, active transport, and endocytosis. What is passive diffusion? Basic characteristic of passive diffusion. Who are my microbiologists? Hey guys, how you doing? Passive diffusion. Nobody else over here is taking micro, right? So you're the two experts. You don't remember?
I'm not taking it, but is it where it doesn't need help?
Does it need help, and in what form? What do you mean by help?
Doesn't need a carrier bonding, doesn't need anything else bonded to get it to like the cell walls or absorption or.
Doesn't need energy.
Right.
Okay, ATP is not required for it. So if we're looking at facilitated diffusion, is there any energy needed for that? No. It just means that it's being facilitated through the proteins. It means they're either going to be the right size or right shape to go through those proteins, but no energy is needed for that.
So both of them don't need energy?
Both those two do not need energy. But when we talk about active transport needs energy, needs ATP, or like you said, another substance to bind onto it, where you have co-transport into them. Okay? And then there's endocytosis. What is endocytosis?
I know that.
You know what that one is? What is endocytosis?
I don't know, but I know.
It's where something comes up to the cell, and the cell invaginates and brings it into a vesicle, and it is processed through the cell that way.
Okay.
So that's the cell actively bringing something into it. Okay, know the difference between a bolus and chyme. I talked about that. Bolus comes from the mouth into the esophagus, into the stomach. After it has been processed in the stomach, then it becomes chyme, okay? Bolus is not acidic, chyme is acidic, okay? Know about the different types of digestion, chemical, bacterial, etc. Okay, chemical, we know about that. How is chemical digestion accomplished? Acid or what is some of the forms of chemical digestion? So he said acid, which is true of the stomach. Enzymes. Enzymatic activity is the other form that's going to happen. Bacterial, that happens inside your colon, where the bacteria in your colon are going to help digest some of the fibers and other materials that you cannot normally digest. So know the enzymes associated with digestion. Where, how, and what is digested. So we talked about that when we went through the organs. The enzyme in your mouth. What's so funny?
Nothing.
Enzyme in your mouth. What type of amylase? It's in the mouth, your saliva, salivatory amylase. Usually associated with the organ that we're talking about. In the stomach, is there any enzymes working in there? No, it's mostly chemical because of the fact that you have hydrochloric acid, and any protein-oriented thing such as an enzyme is going to be degraded, right? Because we talked about pH, the effect of pH on proteins. Now, when we get into the small intestine, now we have enzymatic activity again. So we have